What are wholesale energy markets? First, let's take a step back. The electricity sector is structured differently in different countries and regions. In many regions, the production, transmission, distribution, and sale of electricity is all done by one company or a few companies, each covering a distinct geographic area. In this case, the company is considered to be vertically integrated, as illustrated on the left. These companies are regulated as natural monopolies to ensure that customers get reliable power at reasonable cost. Some countries and regions have introduced competition, separating the ownership of generation assets from transmission and distribution assets, and allowing for competition in retail supply of electricity, as well as in the wholesale market. In this case, the companies owning transmission and distribution infrastructure continue to be regulated as natural monopolies. However, there is competition for generation in the wholesale market and for supply in the retail market. In this case, the system is often said to be unbundled or deregulated. Without going into this too deeply, it's worth noting a few points. First, there are plenty of hybrid examples. So the graphics here are an oversimplification. Next, markets for electricity are still highly regulated, since any imbalance in supply and demand can have catastrophic consequences. And regulating the frequency of the grid requires constant monitoring and operations. Now let's focus our attention on the wholesale market. The wholesale electricity market operates over many time frames. Here we have a wedge representing these time frames. On the left you have years, and on the far right you have the moment of delivery in real time. The market is structured to ensure that on delivery, in real time, the electricity system is perfectly balanced between supply and demand. Parties make contracts for years and months in advance. However, because of the need to adjust to changing circumstances, for instance, fluctuations in demand, changes in weather, power plant outages, and other reasons, important trading happens in the day-ahead market and on the intraday market. Between an hour to 15 minutes from real time, the system operator will take over the procurement of resources to be sure that they get exactly what's needed to balance the frequency of the network. Why does this matter to buildings? In short, there can be market opportunities to sell energy efficiency and demand response into some of these markets. If you look at the two rows at the top, you see the different types of markets that operate in these timeframes. Markets operating years and months in advance include capacity markets and forward markets. In this time frame, you also have transmission and distribution companies making investment plans on new infrastructure and network maintenance and upgrades. We'll come back to the networks a bit later. You then have day-ahead and intraday markets. And finally, anywhere from an hour to 15 minutes before delivery, you have a balancing market, ancillary services, and reserves, all of which focus on evening out supply and demand as delivery time approaches. Then in the bottom two rows, you have types of resources, dispatchable and non-dispatchable. Dispatchable resources are any resources that you can turn on or off and up or down. Non-dispatchable resources are those that it will be difficult or impossible to turn on or off as needed, but they can be available all of the time, or at least during the times where you would see an impact thanks to energy savings. The focus on the bottom two rows is exclusively on demand-side resources, that is, on energy efficiency and demand response. Here, dispatchable resources are primarily demand shifting or demand response. Demand response can participate in capacity programs, demand bidding in the day-ahead market, and special programs aimed at contracting end-use customers to be available to shift demand to respond to emergencies. System operators might also contract resources so that under specific conditions and within agreed parameters, the system operator can directly turn down a consumer's energy use. Non-dispatchable resources can be counted on to help reduce system demand, but without the added on-off or up-down switch of demand shifting. Over long time frames, energy efficiency programs, including utility obligation programs, can reduce overall and peak demand on the system. Time of use rates, where price increases and decreases correlate with the amount of demand on the system, can also have the effect of reducing overall demand. There are also retail pricing structures that can reduce customer demand in a day-ahead or hourly time frame by either raising the cost of electricity during critical peak times or offering rebates for reducing consumption during critical hours. It's also worth noting that energy efficiency and demand response can also help reduce the need for investments in transmission and distribution networks. It's also worth noting that energy efficiency and demand response can also help reduce the need for investments in transmission and distribution networks. While this is not a market, as network company investment plans are reviewed by regulators, there are examples of network companies having regulatory approval, or even a requirement or incentives, to invest in cost-effective demand-side alternatives like energy efficiency and demand response. While this chart may be a bit much to absorb all at once, it's useful to come back to when considering how different demand management options, energy efficiency or demand response in different time frames and for different end uses, might be bid into existing markets, as well as a component of distribution and transmission company investment plans. The rest of this section provides some examples to help understand how these types of opportunities are realized in practice.